I have a design for an old tank, and we're redesigning it now to make a new tank. And the new tank is different in its dimensions in a certain way. It's, let's see, it's increased the circumference by 5%, and it decreased the length by 15%. So it's a little bit wider in the circle portion, and it's a little bit shorter in the length of the tank. And what I want to do is make this little table here where I write down the things I know. Now, I've already put 2 pi r for the circumference of the old tank and L for the length of the old tank. We don't know what those are, but let's just put them there for placeholders. I think they'll be useful. And what's the new tank's circumference? Well, it's increased by 5%. And the way we say that in math is 1.05 times what it used to be, right? That's 5% larger. So that's going to be 1.05 times 2 pi r. And the length of it will have decreased by 15%. That's interesting. So that means 0.85, right? 0.85 times L. So I want to ask you, what's really changing here? Is pi changing? No, no one's changing pi. That's been the same for thousands of years. That's not going anywhere. It's r that's changing. So why don't we just get rid of the 2 pi r, right, and make things less confusing? Okay, and this isn't the circumference that we're really talking about. It's the radius. Really fat writing on that. It looks weird. It's the radius that's changed. Okay, the radius got bigger. So what effect will that have on the new volume? Well, we have to know what the volume of a cylinder is, and this is kind of a big deal. If you have a cylinder, looks something like this. Okay, there's my cylinder. The radius is how wide that circle of the cylinder is, and the length is obvious. That's how long the cylinder goes, the pipe. Well, your volume is going to go pi r squared, which is just the area of the circle, times the length of the pipe. You can imagine that circle sort of sweeping its way along the pipe to make a total volume. So there's my equation. But look what's happening here. In this new equation, pi hasn't changed, but r is now turned into 1.05 r. It's still squared. And L has turned into 0.85 L. Okay, well, what effect is that going to have? Let's go ahead and punch some things in our calculator here. This is going to be still pi, and 1.05 squared is 1.103 r squared, and then times the 0.85 L. Well, I can multiply in any order I want. So I'm going to choose to multiply the numbers together and just get pi r squared L by itself with all these numbers over here. Here's my 1.05 squared. We're calling this 1.103. And my 0.85. Okay, I'm keeping those over to the right. So that when all the dust settles and I multiply all the numbers together, what's going to happen here? I have 1.103 times 0.85, which is going to be 0.9375. Okay, now that's our answer. Let's take that and compare it to the options that we have way in the upper left. Okay, so I have 0.9375. That's how much the volume has changed. In other words, it's dropped. It has not gotten bigger. Okay, so we can rule out all these things where it got bigger. It's dropped. Well, how much did it drop by? 5% or 10%? Which do you think this number that we have is closest to? 0.95 or 0.9? Well, I think 0.95 is the winner. It's not exactly right, but it's the closest we have to our answer. Now let's talk about the things that can go wrong in a problem like this, because people mess this up all the time. You know what would be wrong? Saying something increased by 5% and decreased by 15%, and just saying plus 5% minus 15% to get 10% down, right? That's sort of a simple way of looking at this that doesn't account for the equation. Because your equation has a squared in it with the radius, it's going to make the effect of radius changes bigger, right? Your very small increase in the radius of the tank is going to have a bigger effect than you would expect because it's squared.